Hey, Intermediate Algebra. Here we go with some more word problems. Word problems day 2. Remember, to solve word problems, start by reading and understanding the problem, which I think is probably the most difficult thing. It can really help if you can put the problems in your own words. Like, you try to describe it as a story, maybe to somebody else or to some imaginary friend in your mind. And I always start with the words, so there's this guy, or so there's this girl, or so there's this dog, or so there's this something, probably some noun, that's doing something, trying to buy a coffee shop or trying to create a nice barn or I don't know, doing something. But if I can think of what's happening as a story, I have a better shot at understanding it and also of trying to figure out what it is I'm looking for, what I'm trying to actually do. The most important mathematical step is to correctly define your unknown. Typically we pick x, although in this first problem down here we'll pick w or l. Pick the thing that's least whenever you have the option to do that. If there's multiple unknowns, write the other ones in terms of your first variable x. And set up equations, solve, and check them. Okay, this is all the mathy stuff that at this point we've done a lot of practice of in our lives. Solving and checking is simple. Finding the equation, creating the equation is what's difficult, and that's actually what's valuable out in, the quote-unquote real world. Okay, the perimeter of a rectangular field is 240 yards. The length is double the width. Find the length and the width of the field. I'm going to just start by sketching out a nice pretty little field here. Yep, I'm on a highlighter. I'm going to try to make it so that one side looks like it's about twice as long as the other. So right now this is set up to where this would be my width and this would be my length. I think the terms width and length are confusing actually. Like I tend to think of width as being what's wide, so width is wide, but I also think of length as being what's long. The length is the longer side, or the log-in side apparently. Maybe you don't have that problem like I do, but for me width and length are pretty ambiguous. It doesn't really matter, except for here we're told that one side is double the other. So right now the length is 2 times as long as the width. Okay, we're going to have to work with the information that we have to solve this problem. The first thing is we're told the perimeter of a rectangular field is 240 yards. Well, there's two things I know. One is the perimeter is 240. But two, I know it's a rectangle. And to find the perimeter of a rectangle, it's 2 times the length plus 2 times the width. And maybe you didn't know that, but I just did a sketch and it's a rectangle, so we know there's length plus width plus length plus width. So it's 2 lengths plus 2 widths. So I actually can start with the equation 240 equals 2L plus 2W. Okay, because the perimeter is 240, so 2L plus 2W must add to 240. Now this currently has 2 variables in it, and having 2 variables with just one equation can't be solved. But luckily we have more information. We're also told the length is double the width. Okay, I haven't really set up variables yet. Like I've put down a P and an L and a W. But I'm going to define these a bit more clearly. I'm just going to have W equal the width, obviously. But now what I can do, and this is really sneaky, is I can say 2 times W equals the length. Why? Because if the length is double the width, I can write literally length is, the equal sign means is, double the width. L equals 2 times W. Well, if L just stands for length, we know that the length equals 2 times W. Suddenly I can do a little bit of substitution, right? I know that this L is actually 2W because the length is 2W. So I can write the equation 240 equals 2 times 2W plus 2W. And suddenly I have an equation with just one variable. Now just the variable W appears twice. This unknown of W appears twice. So 240 equals 4W plus 2W. So 240 equals 6W. So 40 equals W because I divide both sides by 6. If the width is 40 40 yards, then the length is 80 yards, because the length is double the width. And I've solved the problem. Turns out 40 plus 80 plus 40 plus 80 does equal 240, so it checks. I satisfy both conditions. The length is double the width, and the total perimeter is 240 yards. Sweet, we did it. Way to go. Notice how we defined everything in terms of the smaller object. Width was less, so I made it my variable that I worked with. My equation ended up having a bunch of w's, not a bunch of l's, because you want to work with whichever is less. All right, let's move on. In a triangle, the measure of one angle is triple that of the smallest angle. Additionally, the third angle is 20 degrees more than that of the smallest angle. Find the measures of all three angles. Okay, we have three angles to work with. I'm going to draw a bad triangle. I'm going to call this triangle, that angle x. So its degree measure is actually x degrees. I don't know the number of degrees, but I'm going to set up that x equals the measure of the smallest angle. And that's important. It's going to be the smallest angle. Well, then I know that one angle is triple that of the smallest. So 3x equals measure of, I'll just call it the second angle. I'm not sure if it's going to be the biggest angle or the middlest angle. All right, I know it's not the smallest, but it might be the biggest, it might be the middlest. I don't know. My third angle, so one of these is 3x degrees. My third angle is x plus 20. Again, this is probably going to be the middle angle in terms of its measure, but I don't know, so I'm not going to define it that way. Now, because it's a triangle, we know that angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3, all has to add up to 180, and we can solve, because this angle here was going to be x plus 20 degrees. Well, we add all this up, we get 5x plus 20 equals 180, which means that 5x equals 160, and 160 divided by 5 is 32. My first angle is 32 degrees. My smallest angle is 32 degrees. So then my next, I know I have a 96, and I know that I have a 52. So my angle measures are 32, 52, and 96. (32 plus 52 plus 96 is 180. This one is triple this one, and this one is 20 more than this one, so I satisfy all the requirements. Those are my angle measures. Again, we had to know something. We had to know that all three angles combined to 180, and then we had to work with the other stuff that we had. Okay, last one. After a sale of 30% off, a box of cereal costs $2.24. What was the price before the sale? Now this is problems we've actually done before. This is just percent change. I want to remind you, you can set this up two ways. Okay, we'll just have x equal the initial price. That's what we're trying to find. We don't know the new price, we know the initial price. So I can take the formula that I've given us, a equals b times 1 plus or minus r. And that doesn't have an x in it anywhere, which doesn't feel very helpful. But this base was our initial price. And we know that it's going down 30%. And when we take our initial price and drop it by 30%, that is going to come out to $2.24. Okay, initial price dropped by 30%, came out to $2.24. You can again think of that as, if I take away 30%, that means I'm really leaving 70%, 1 minus 0.3 is 0.7. So divide both sides by 0.7. X equals 2.24 divided by 0.7. 320. The box initially cost 320. You can also do new minus old divided by old equals percent change over a hundo. And we get the new price is 224. The old price we don't know. And that's our percent change over 100. You would solve this by cross-multiplying, dividing, etc. We've gone over that, so I'm not going to spend the time showing it again, but that's how you'd set up the proportion. Okay, a few more examples of word problems. It always comes down to just defining your variables and setting things up correctly. Make sure when you're done, your answer makes sense. 320 is definitely a reasonable way to drop 30% to get to 224. Well done. See you next time.